Hey everyone, welcome back to our channel. Welcome to our exploration of K nearest neighbors KNN algorithm. Today we will delve into KNN, a fundamental concept in machine learning. KNN is a simple, powerful algorithm used for classification and regression tasks. Let's uncover its key aspects. Why do we need KNN? What is KNN? How do we choose the factor K? When do we use KNN? And how does the KNN algorithm work? To start with, imagine you are a young child learning to differentiate between cats and dogs. You can do this by observing their similarly. Cats have shaped claws, smaller ears, and meow, while dogs have dull claws, larger ears, and bark. Similarly, KNN classifies data based on features similarly. If we have a new picture, we compare its features with those of known pictures of cats and dogs to determine its classification. Now, let's talk about the KNN algorithm. KNN stands for K nearest neighbors. It classifies a data point based on the classification of its nearest neighbors. The permanent K refers to the number of neighbors considered. Choosing their right K value is crucial. Too low and it might overfit the data. Too high and it might underfit height and a fit. Typically, the square root of a total number of data points is used as K, and it's often made odd to avoid ties. KNN is suitable for labeled data, small data sets, and when the data is noise free, it's not ideal for large and complex data sets due to its lazy learner nature. Imagine we have data on height and weight, and we want to classify individuals as normal or underweight. We calculate the Euclidean distance between the unknown point and all other points. Then we select the K nearest neighbors based on the shortest distance. The majority class among these neighbors determine the classification of the unknown point. It's like taking a vote among the neighbors. That concludes our journey into the K-means neighbors algorithm. We have covered its basics, applications, and how it works. That's for joining us today.